Good morning to all of you. Welcome to Chopra's School of Physics. As in the earlier cases, like in the previous video you have seen, we have estimated the speed of electron around the nucleus of hydrogen atom and other things which we can calculate using some other chapters of physics, that is time period, current, then total energy. These all facts are to be estimated. So now we are continuing with how to estimate the time period and the current due to electron. So in the previous video we have applied centripetal forces and electrical forces, and now the formula of time period you must know. Time period is estimated by function T is equal to distance over speed. Now see, this formula we have taken from mechanics. It means this particular question requires the application of mechanics also. So it means that we have to understand, we must know the different concepts of mechanics, then certain concepts of heat and light, electromagnetic radiations. So it means that we have not to simply depend upon electrostatics in solving the question. It is a basic point to use electrostatics. The other chapters with respect to their principles we have to apply in the question. So now here we are finding time period is distance over speed. Now it is a matter of common sense that when electron will revolve, obviously the distance covered will be circular. So when we use the circular distance, we have to take the circumference, that is called the distance. So distance covered by the particle in circle is equivalent to the circumference of that circle. Now what is the circumference of circle? It will be 2 pi r. So what you are finding? Now we are using mensuration, mathematical aptitude. So mensuration is to be applied. So you must have a very good idea of mathematics also, how to use mensuration in physics. So the backbone of physics is basically mathematics. Mathematics is the queen of sciences, and that is what we have to apply here in this question. So it is now 2 pi r. Here I am writing 2 pi r, and v is supposed to be the speed. And if you will recollect, we have estimated speed earlier, and speed was estimated by function E times the square root k by r. With examination point of view, you have to remember the formula. We have not to make a derivation of the formula. It is for the academics. We are discussing all the things, all these principles for competitive examinations or the entrance examinations. So, here we are going to apply the speed here. We will eliminate the speed and will bring our result in terms of radius, because radius is the principal point which is given to us in all the questions. So, now we will write T is equal to 2 pi r divided by E times square root k over r. So time period of this electron 2 pi r divided by speed, and speed is taken as E times the square root k by r. Now it is all a mathematical evaluation. The basic mathematics which you have learned in the academics in the lower classes, that is to be applied here. So a typical formula will arise, and that formula you have to remember in the examination. We have not to drive this composition, we have to apply this composition. So now we can write like this: T is equal to 2 pi over E. 2 pi over E. This R, square root R, taken in the numerator, this is power 1. So we'll write now this function R root R M divided by K. Once more, 2 pi over E. Rm root taken in the numerator. This R we have written here and K in the denominator. You must know R root R. What is R root R? So how to write R root R mathematically? It should be taken as T is equal to 2 pi over E square root of. This is R to the power 1 by 2. So 1 adding to 1 by 2, 3 by 2. So T is equal to, we will write R to the power 3 M over A, like this. R root R. I will slightly more elaborate. R root R when we write like this, we write the square root, then we write R square into R. Now you must have a logic of this calculation. When R is taken in the square root, it should be written as R square. Because if you take square root of R square, it will become R. So instead of keeping it here, we will put it in within the square root in the form of R square. Here, the power is 1. So R square multiplied by R, that will be root of R to the power 3. This is how we got R to the power 3. Now, pi is constant, E is constant, pi, E, M, K, all functions are constant. All numbers are constant. So T proportional to square root R cube. We can expand it more elaborately. T is directly proportional to R to the power 3 by 2. Now this is a law to be remembered, to be applied in the various questions. T proportional to 3 by 2. R to the power 3 by 2. So we can also say that if there are two orbits, then we can write T1 over T2, that is equal to R1 over R2 power 3 by 2. Now it will be a competitive question. That is, suppose if there are two orbits, suppose these are two orbits like this. One has radius r and other has radius 4r. Time period for the inner electron T1. Time period for the outer electron T2. Now our question is find T1 over T2. So we have not to solve the whole thing. We have to apply this composition. So in the examination we have to cut short the time also. That's more important. Because within a stipulated time, we have to solve our questions. So if there are 60 questions or 50 questions, we are given just 50 to 60 minutes. So if we know these principles, then we can solve the question easily. But otherwise, if we start driving out the functions, it will be very difficult. One question will be completed in 10 minutes. The rest of the paper will be left behind. So it means we will be out of the competition. So that's why now it is T1 by T2, R1 by R2, power 3 by 2. Our question is of this pattern, that inner radius of electron revolution is R, outer orbit 4R, find T1 over T2. So we will say that is T1 by T2. If we wanted to find this number, what should we do? T1 over T2, that is equal to R, because here we are writing R1 by R2. So it is R over 4R power 3 by 2, like this, according to this composition. R will cancel off. So T1 by T2, it is 1 over 4 power 3 by 2. So we can say like this, 1 over 2 square power 3 by 2. Now this is 2 square. So what should we do? It is 2 square. It means here we will write this one, 1 by 2 square. This is 3 by 2. So how to solve this? This is all a mathematical evaluation. We have written 4 as t to the power 2. Try to make the function such a way that we should get a proper number. So now what should we do now here? Because 4 is written like this, so we will write it like 1 over 2 power 3 over 2 multiplied this one 2. So how we have written this number? 1 square will remain 1. So 1 to the power any number will be 1. So it will be, we have written 1 over 2 and this 2 is taken here. So 2 will cancel. 1 by 2 is written as 1 over 8. So T1 over T2 equals to 1 over 8. This is what our answer to this question. We can say ratio T1 is to T2 will be 1 is to 8. It means that when we say T1 is to T2 is 1 by 8, inner electron, this inner electron and the outer electron, we will find the relation like you have written earlier, that is T is directly proportional to R. If R will be more, time taken will be more. It means that if electron is revolving, in inner radius, electron will move more faster as compared to the outer electron. So speed of this electron will be more, speed of this electron will be less. Time period taken less here, more here. Right? I hope this type of estimation is clear to you, and the remaining numbers you can estimate by using different formula, like current is estimated by formula I is equal to E over T. I is equal to E over, and T will be 2 pi R over V, and more elaborately it should be E V over 2 pi R, like this. So here V is to be computed, and V you have already written, V is given like this. If you put V here, our conclusion will be I inversely proportional to, like here it was directly proportional, here I inversely proportional to R to the power 3 by 2, like this. We will reach to this conclusion. Similarly, if total energy we have to find, you must remember that electron by revolving must have kinetic energy as well as potential energy. In this question you are finding we are using the various chapters. The same will be the situation when we will discuss other questions also. So, if you wanted to find total energy, the total energy can be written as total energy, kinetic energy plus potential energy. This concept is to be applied to find the total energy, and we will find that total energy of electron that will also come in terms of radius. Similarly, wavelength. If we wanted to find the wavelength is h over mv. So again we are finding V here. V should be eliminated, and for V we should compute E times square root k by Rm, and again we will come to a conclusion that wavelength is also related to radius. I hope this is clear to you. So wavelength, if you wanted to calculate, it is h by this, where h stands for Planck's constant. Planck's constant. Its value is 6.6 10 to the power minus 34 joule seconds. I'm using joule second. Joule is work, second is time. Work and time, this product, this will be taken for Planck's constant, and the product of the two numbers will be angular momentum. So dimension of Planck's constant is the same as that of the angular momentum. So these are all the illustrations I have explained to you, and you have seen in this illustration that just electrostatics won't work here. It is a principle to be adopted, but many other chapters are involved in one question. So our all questions will be like this, that how to apply the various formulas from the various chapters, and like this we'll also discuss the concepts of the other chapters to solve the other questions. Well, so students, I think that you have enjoyed the estimation of these questions. We have discussed one question, and you remember that when we do the physics portion or the physics questions, in one question we use many topics, like we use electrostatics, we use current density, we use atomic physics, and we use mechanics portion also, like you have seen in this particular video, that you have seen that we have applied the mechanics also, centripetal force, centrifugal force, and it is correlated with electrical forces. Similarly, we have to relate while finding the wavelength. Atomic physics is to be related to electron. Similarly, time period is to be estimated. And that's why in one question we find that it is not just one chapter is to be involved. Many chapters are involved in solving a question. So in the examination, we don't expect that question is coming topic-wise. The question is given in such a way that in one question, say about 4 or 5 topics are involved. We take second question, in that we again find many other topics are involved. The whole physics is made up of many chapters which are involved in the various questions. So it is not like that topic-wise you are going to apply. You have to remember that all the topics must be thorough and clear with you, so that the moment you see a question, you must immediately think of that to solve this question, what principles are to be adopted, which chapters are involved in this, and for that you require a lot of practice. So practice is very important, and if we will not do more practice, then it means it will be very difficult, because the subject is very complex. So you will remember that we can understand physics, it's a very easy subject, but we have to reason, we have to adopt logic, we have to know which formulas can be adopted to solve one particular question. Thank you very much.